All right, guys, we'll get started. So we're on the binomial probability distribution formula. So, this will flow on from yesterday, and my apologies about my performance yesterday. I'm feeling much better today. So we just get straight into the content. Just to recap some notation, okay, we've heard about normal distributions before, and when we have a random variable, it could be normally distributed, okay, in which case we'd say the variable x is normally distributed with a mean and standard deviation squared, okay, that's one way we can notate the normal distribution. And similarly for a binomial distribution, which we'll explain what they are in a moment, we have x is binomially distributed, b for binomial, n for normal, and we have number of trials and probability of success. Now this is the BPD formula, the binomial distribution formula, and it's probably going to make sense, I think, if we just get straight into the example to calculate it, and then we can apply the apply it straight to the example. So here we've got some apples. So we'll jump down to the bottom where it says the probability that an apple is rotten is 0.35. So this is following 9E tree diagrams in your notebook. All right, what page is that one? 34. Okay. The probability that an apple is rotten is 0.35. There are 8 apples in a bag. Okay. Determine the probability that, we've got A, exactly 3 apples are rotten. So in this circumstance, what's going on? We have a binomial distribution, we have a number of trials, that's how many apples are present. We've got 8 apples. We have the probability of an apple being rotten. Sometimes we call that the probability of success. And you might think, an apple being rotten, that's not very successful. But we're testing here for the number of apples being rotten. So we would denote the probability of success as 0.35. And then the other thing we need is the probability of failure. Now these are binomial, which means there's only 2 possible outcomes. Either it's rotten or it's not rotten. And so if the probability of it being rotten is 0.35, then the complementary probability is 0.65. Remember, all probable events sum to 1. Those probabilities added together will be 1. They're the only 2 events that can occur. You can have a rotten apple or a not rotten apple, a success or a failure. Okay, so if we want to calculate the probability that exactly 3 are rotten, we're calculating the probability of x, the binomial distribution, being equal to 3. And so we'll just follow the formula straight here. We have 8 trials, and we're talking about 3 successes. Now, when you type it in your calculator, you do need to put times in. People have got syntax errors in the past because they haven't put the times there. Times P, the probability of success, 0.35, to the power of the number of successes. All right, we're talking about 3 successes. You can see those relationships here anyway. This is the number of trials. This is the number of successes. We're talking about 3 successes. 3. The probability of success to the number of successes multiplied by the probability of failure to the number of failures. If we have 3 successes and there's 8 apples, that means there's going to be 5 failures. And so this is what we'll type into our calculator. Now, just to remind you how we bring up C, it's in run map, and we go option across, I'll write it down. Option across prob, and we've got NCR. And we're going to type it in 8C3 times 0.35 to the power of 3 times 0.65 to the power of 5. Now this is the probability of an event occurring, right? And so I've got 0.2785, 4 figures, and round the fourth, 0.279. So we've got 8 apples in a bag. The probability of one being rotten is 0.35. One randomly selected apple has a probability of 0.35 of being rotten. So if we pull all 8 out and say, what's the probability of having 3 of them rotten? That's what we've calculated here. Okay, the next part, part B, says, how about the probability that exactly 6 are rotten? This time we're finding the probability of X being equal to 6. 6 successes. Alright, so then to calculate this one, we'll be doing C. We've still got 8 apples in the bag, 6 successes. Multiplied by probability of success to the number of successes. And multiplied by probability of failure to the number of failures. So what do we got? 8C6, 0.35 to the power of 6 times 0.65 squared. Okay, so you can see it's far more likely from 8 apples that we have 3 that are rotten compared to having 6. It's almost like over 10 times more likely. Very good. So the questions that you're doing then, they're not in the textbook. I've said this is a sneak peek at some of the Year 12 work. So question 1 and 2 there, we'll get them done before recess, and then we'll come back and do some PCD questions. All right, so question 1 and 2. Any questions about what I've written up there? All right, let's slay it.